we have to provide doubly reinforced section and other things that we have covered previously. So right now I'm going to give you a brief idea of doubly reinforced section. So say for example, one of the example of any of the doubly reinforced section. Over here some tension reinforcement is provided, over here some of the compression reinforcement is provided, neutral axis is located somewhere here. Now to understand it, what we need to know is it's a stress diagram and strain diagram. So this I'm going to draw first of all strain diagram. Maximum strain carrying capacity of your concrete is 0.0035, and from this side you can find out the value of strain with the help of equation epsilon SC, that is equals to 0.0035 bracket 1 minus d dash divided by xu. With the help of this equation you can determine the strain of concrete at the level of reinforcement. So this is the level of reinforcement. Now if you draw this stress diagram, then it will look like this, your stress diagram like this. But before drawing this stress diagram, what I'm going to do is I'm going to divide your section. This one is your doubly reinforced section, and doubly reinforced section, for simply to make it simple, I'm going to convert these into the two type of the section. This one is your doubly reinforced section, and for your simplification I'm going to divide it into the two part. So first part is your balance singly reinforced section. So this one is a balance section, but balance the singly reinforced section. So and another that I would like to draw is a auxiliary section. So this one is your auxiliary section, additional reinforcement that are required for these doubly reinforced section. So this one is your additional or auxiliary section. So you can say this one is a auxiliary section. So stress diagram for singly reinforced section, that you know the maximum capacity, that is maximum design value of concrete is 0.446 FCK. This value is a C force, that you know the value of this is 0.36 FCKB into XU, and this amount is 0.42 times of XU. And over here one tensile force 0.87 Fy into AST1. This AST1 that is for balance section. Now another stress diagram that is for auxiliary section, that I'm going to draw it over here, and it will look like this. This is your neutral axis. So again over here your amount is same 0.446 FCK, but at the level of reinforcement, force is acting, that is known as a C2, that I'm going to consider as a C1. So what is the amount of C2? C2 is nothing but FSC minus FCC into ASC. Now let's learn one by one term, and this one is your lever arm Z1 for balance singly reinforced section, and this one is your T2, and this amount is T1. So you can say this one is a 0.87 Fy into AST2. So distance between these two, that is known as a Z2. So Z1 you all know very well, D minus 0.42 times of XU, and Z2 is equals to D minus D dash, because it's at the level of reinforcement, compression reinforcement. So and the distance of this from extreme top fiber, that is D dash, that is a top cover. Clear? So now let's summarize all the equation. These all things we have covered in previous lecture, in my lecture. So I'm going to write it down one by one. C1 is nothing but 0.36 into FCK into B into XU. Now C2 is equals to FSC minus FCC into ASC. Now you know all the terms of this, but in this you must know about the FSC. Now what is the meaning of FSC? So FSC is nothing but stress in compression reinforcement, or you can say this one is a stress in steel at the compression zone. Like this also you can remember this. Same way FCC. So what is FCC? So compressive stress in concrete, because stress in concrete, but where compression is located. So in concrete at the level of compression steel. Clear? So now let's find out the value of T1. So T1 is nothing but 0.87 into Fy into AST1. Remember, AST1 is for a reinforcement for balance singly section, and value of T2, that is nothing but 0.87 into Fy into AST2. Clear? So like this way you can determine each and every term. Same way Z1 is nothing but D minus 0.42 times of XU, and Z2 is nothing but D minus D dash. Clear till now? So these all formulas you need to understand very well. Now let's find out the equation of moment of resistance. So I'm going to write down equation of moment of resistance. So moment of resistance of doubly section, that equals to moment of resistance of balance singly RC section plus moment of resistance of auxiliary section. So you can convert this into like this: moment of resistance, that is equals to moment of resistance for balance section. So that is nothing but mu lim plus mu2. So what we need to find out? We need to find out value of mu2. So ultimately you need to do two type of example. First one is your analysis example, and another one is a design example. So you all know in analysis example you have to calculate value of moment of resistance, and in design example you have to calculate value of AST and ASC. Over here ASC is the area of steel in compression, and you know AST is the area of steel in tension. So let's first of all find out the value of mu2, or we need to calculate value of ASC as well as AST. So in this, AST is equals to AST1 plus AST2. This is for balance section and this is for auxiliary section or additional reinforcement. So for that I'm going to use mu2, that is equals to mu minus mu lim, and this equation can be derived from this equation. So mu2 is equals to mu minus mu lim. So from this we all know mu2 is equals to T2 into Z2, or you can use C2 into Z2. So let's find out first of all. Then we can equate these and these. So you'll able to get the answer of AST2, because you know the AST1. How to determine AST? So AST1 is nothing but PT lim into BD by 100. So this is for singly reinforced section. So nothing new in this. So we need to calculate value of AST2. So T2 into Z2, that is equals to C2 into Z2. Z2 get cancel out. So you have two equation only. This is your 0.87 into Fy into AST2, that is equals to FSC minus FCC into ASC. So now let's find out the value of AST2. So AST2, that is equals to FSC minus FCC into ASC divided by 0.87 into Fy. So now the thing is, what we need to find out? We need to find out the value of FSC, we need to find out value of FCC, and we need to find out value of ASC. ASC you can easily get from this equation. mu2 is equals to C2 into Z2, and from that you'll able to get the answer of mu2 from this equation. And now you need to calculate value of ASC only. So you will get the answer of ASC from this equation. Then by equating these two, you will able to get the answer of AST2. But how to find value of FSC and FCC? I'm going to tell you. Just wait a minute. Before that, this is our final equation to determine the value of AST2. If you don't want to remember this equation, then it is given in IS 456 page number 96. You'll able to get the same equation. Okay, now let's understand the concept of FCC. So what is the value of FCC? So FCC is, again I'm going to repeat, what is the value of FCC? So FCC is nothing but compressive stress in the concrete at the level of compression reinforcement. So again I'm going to draw this stress diagram. So it will look like this. Some of the part of this is a straight, but the design strength of concrete is 0.446 FCK. Now to determine the value of FCC, you can see from this chart, the value of FCC is going to be decreased as distance from the extreme fiber is going to be increased. Clear? So what you can do is either you can neglect this, don't worry, you can neglect it. In any case, you can neglect it, but up to d dash by d 0.2, ratio of d dash by d 0.2, you can take FCC is equals to 0.446 FCK up to d dash by d 0.2. Then what will happen? Then your this is going to be decreased, and again at this location is going to be 0. That's why if you want to neglect it, then it is fine. Now FCC value, you know the value of FCC. Now how to determine the value of FSC? So FSC for mild steel, you can take this FSC is equals to 0.87 into Fy. 0.87 into Fy. Otherwise, this is for mild steel. Fy is equals to 250 grade. Otherwise, what you can do is for higher grade of the steel, say for example 415 and 500 and above grade, what you need to do is you have to follow the SP16 table, page number 13. SP16 page number 13, table F. From this you will able to get the answer of FSC, and that depends on the d dash by d. So if you want to derive the value of FSC, then just I'm going to give you the hint. What you need to do is you need to first of all calculate the value of strain, and strain that can be calculated with the help of this equation. This is also given in the IS 456 page number 96. So that is 0.0035 into XU max minus D divided by, sorry, this one is a D dash divided by XU max. You will able to get the answer from this. So epsilon SC, with the help of epsilon SC, you will able to get the answer of strain, and then from figure 23A, page number 70, IS 456. From this, you need to calculate value of this is a stress strain diagram. So from this, you will getting the value of corresponding stress. And this diagram, this figure is look like this. This one is a stress, this one is your strain, and somewhere over stress is there, and your graph is look like this. So from this, you will able to plot this from this, and from this you can get the value of strain. And over here they have mentioned some of the value 0.87 Fy, 0.85 Fy, like this. So you will able to get the answer of corresponding stress, and that is equals to any value. Say for example, you can find the answer 0.86 Fy also. So like this way you can calculate the value of strain for this location. Now this is your first part. Now what you need to do is, there are basically, just a minute. Okay, there are basically two type of the example. So